Okay, we're going to start Wednesday's homework. We're doing 55, 56, and 57. Again, we're in the green packet, just a reminder. In 55, they're talking about a situation of people playing baseball. Gosh, I just don't know. I'm not sure we're going to see any baseball games this year. We'll see how that goes. We certainly won't be in the stands, it doesn't seem. Okay, so they're saying I have a total of 12 home games. 12 home games, okay? And they've already done the equation for us, so I'm just, showing you the pieces, where they got the pieces of the equation. They already played 6. 6 are done. Those are done. Those are home games, and they are done. So they've already played them. Then they're saying that 1/3 of the rest of the games, that's over here, 1/3 of the rest of the games are going to also be home games. So 1/3 of the games they have yet to play, plus the 6 games they've already done, that is going to be their total of 12 home games. And they're saying, so like G is all of the games they're going to play. So first thing we're going to do is we're going to say, well, let's get rid of the games, the home games that they've already done. I don't really need those. I need to know how many are left. So over here on the right side, I have 6 games left. And I know out of those 6 games are going to be 1/3 of the rest of the game, of all the games we get to play. So if that's true, what is G? So I'm looking for, I want to get rid of, I want to undo or get this down to G. So what am I going to do to this 1/3 to get G? That, I need 1, right? That's going to have to be 1G. So what would I multiply 1/3 by to get 1? And if whatever I do to the G side, I have to also do to the 6 side. And that's all I'm going to give you. We've done a bunch of these. And so if 1/3 G is 6, what would G be? Okay, I'm going to move to 56. And 56 is shopping. So I don't know. Unless you're doing this online, you're probably not going out and buying clothes. But here's what this problem says. This problem says we bought sandals, we bought 2 t-shirts, jeans, not sure how much those cost, and we had tax. And the total was $43.87. So I'm going to set up an equation here. So first thing I'm going to do is I'm going to say, okay, my sandals were $8. I bought 2 t-shirts for $9.49. All right, 2 of them. I paid tax. I'm putting all the money I know together, okay? And then I paid something for jeans. I don't know what that was, but that equaled together $43.87. So the first thing I'm going to do is I'm going to combine all of this. That's what I would do. I would combine all of that, because once I know what all that is, I am going to know what's left out of the $43.87 to tell me what the price of those jeans were. So I would add this, okay, add those together, and then subtract that from the total, subtract it from here, and then I would know what was left for the jeans. So that would be my approach to 56. 57 is great. It's a great problem because it says, it really differentiates between what is theoretical. In other words, what should happen? According to mathematics, what should happen in that probability? The difference between that and experimental, when I actually do it, am I getting the same probability numbers? Okay, so I've got theoretical. This is what the numbers tell me. Okay, this is the math. Experimental, well, how did that really turn out? So we did this in Amplify with the candy, the Skittles. Okay, we said, what is the probability? What should be the probability for each of the colors? and then what actually turned out to be the probability. So in the theoretical probability, I'm adding up all the possibilities. Remember, it's always out of the total. Okay, my total there is 30. So I'm going to have out of 30, C would be 15 out of 30. G would be 10 out of 30. And F would be 5 out of 30. And that would be the probability, the theoretical probability, what everything should turn out to be according to the math. And then we do an experiment. Okay, that's always, a little bit different. And you did that in your coin flip, right? You said, here's what I predict according to what I know about mathematics. Said, okay, and this is what I got. Did it come close? Did it not? And so I'm adding up the total, and the total here is 120 for all of them. So G would be 80 out of 120. G would be 30 out of 120. And F would be 10 out of 120. And of course, now I would simplify all of them, to make the probability ratios that they have in the answers. So for instance, if I was looking here at C, I would take this and I would simplify this to 1/2. Okay, and I would simplify the next one to 1/3. And then the next one is 1/6, right? 1 out of 6, because I'm dividing, I'm simplifying them to their lowest terms. And you should do that for the experimental probability. But this very clearly shows that the theoretical probability often is not borne out in experiments unless you do them over and over and over. And the people who find the theoretical probabilities to prove them do something over and over and over and thousands of times to prove that the mathematical concept, the mathematical theory works. Okay, good job.